Hello, name is Joey, and today I'm going to explain the complex circuit I just completed. Though I was supposed to arrange a diagram for this, I had to do a rough sketch because it's an emergency job. So I'm sorry. I have a problem. The client has an inverter of 10 kVA, a small generator of 9 kVA, I think 9.5 or so, and a big generator of 30 kVA, and the grid line, which is we call it NEPA here. So the problem I have is that the small generator cannot charge the inverter because the inverter is 10 kV and the small generator is 9.5 kV. So now the client needs an ATS. It doesn't want the scenario where once you on the small gen, you now have to go and off some certain things and stuff. So yeah, this is a problem, and I'm going to give a breakdown how I arrested it. I have a rough sketch of the diagram here. It should be on the video, and it's crazy. I was supposed to my system crashed. If not, I would have done a proper diagram for this stuff. So I'm going to be explaining each of the circuits. I have 5 contactors. Yes, one contactor is for the inverter itself. The other one is for the small gen, the big gen, the grid line, and then the charging line. Yes, I have to introduce another contactor for the charging line because of the small generator. It can charge the inverter. So, now the inverter is a single phase, the small gen is a single phase, the big gen is a 3-phase, and the NEPA line itself, the grid is just single phase. The way I usually run my connection, I do it in the form of master assembly. You should know. If you've not seen my, I think that video is over, I think it should be up to 5 years ago or something. A video I did on automatic changeover. Yeah, it should be I don't know if I should put it in the description where it should be. I think I will. Just check the description. I'm not really the YouTube kind of person, so bear with me. I'll go through this again. On the inverter line, we have the A1 and the A2. So before power could get to the A1, I'm going to give a breakdown of how everything went. First of all, I'll take power from the live line. So from there, it goes to the emergency stop button. From the emergency stop button, it goes through R1, which is the relay line, normally closed relay line, and then it goes to the normally closed auxiliary of the grid line. Then after that, it goes to the normally closed auxiliary of the big generator, and then it goes to the normally closed auxiliary again of the small gen. Yes, that's because the inverter is more like the servant here. Whenever any of these power comes on, and it has to give way. If it's the small gen, definitely the normally closed auxiliary will open, and therefore it will send the inverter out, making the small gen work. So similar thing happens whenever there's big gen, there's grid line, and so on. So now if you look at the small generator, it's similar to that of the inverter, just that it's a semi-servant. Yes, semi-servant in the sense that it only goes off when there's either grid or big generator. So if you look closely, I have the live line going to the emergency stop button, which is very, very important. And then from there, it goes to the normally closed of the R1, and thereafter it goes to the normally closed auxiliary of the big generator before it gets to the A1. Whenever there's big gen, the normally closed auxiliary of the big gen will open, therefore sending the small gen out. Yep. On the lastly, there's breaker. Yes, there's breaker. Sorry, it's not in the diagram. Escaped me though. Then lastly, the big generator. The big generator, what I have here is the L1 going through the emergency stop button. Then from there, it goes to the normally close of the R1, which is the relay, another line of the relay. Then it goes to the normally closed auxiliary of the grid line before it gets to the A1 of the big generator. So now the big generator is the semi-master. Yes, let me use the word. So whenever this big gen is on, it's only when the grid line comes in. That's when the grid line auxiliary normally close will open, sending the B generator out. Okay, now on the grid line, what I have here is the live wire going through emergency stop button as usual. Then thereafter it goes to a voltage monitor. The reason why I introduced a voltage monitor is simply because they do have low voltage most of the time, and I would not want a scenario where low voltage is really bad for contactors. That's why some people tend to use low voltage contactor for some certain area, because we don't want a situation where they have to go back and change the contacts and stuff. So I don't have space for a transformer, emergency job, so I had to do what I have. Okay, and after the voltage monitor, it goes to the timer. Now it goes to normally open of the timer. Now the normally close of the timer is connected to the buzzer. Yes, so whenever there's light, it makes noise for some time before. It's not as big as a regular grid alarm, so it makes noise for some time before it changes. The reason why I introduced the buzz is simply because they might be waiting for lights or something, and that is just to notify them that yes, this is light you're using now, so that's why I'm using the buzzer. So after the buzzer, after the buzz line, then the timer changes. Sorry, after the buzz line, the timer closes to send power to the A1. Thereafter, send knocking out every other job, and knocking out every other contactor. Now underneath, I have the arrow one. They have 3 normally closed and 3 normally open. So before the coil, the A1 and A2. Now what happened here is that I used the grid line to power the relay. Yes, so whenever the grid line contactor engages, the relay is supposed to engage as well. Yes, if you notice, I use relay and at the same time using the auxiliary, is because in case the relay fails, the auxiliary will be like a backup, because it will be disastrous for the grid line to meet with any of these power supply, the small gens, big gen, or inverter. So that's how I had to use both of them. Like the auxiliary, if you notice, the what's it called, the small generator didn't go through the auxiliary of the big chain, of the grid line, because I only have 2 normally closed. So what I did is that I introduced a breaker just to protect the coil or something. So that's for that. And then on the charging line, I have the generator, the grid line on normally closed. Yes, on the charging line, it's more like a mini changeover. It's a contactor of 4 normally closed and 4 normally open, so I had to just use 2 ports from it. I use 2 of the normally closed to loop it to go to the charging line of the inverter. Then on the grid line, the 2 normally open, I had to do the same. So all right, I don't know if this was helpful, but I would love if you click the subscribe button. It sends a good feedback that yeah, your video was helpful. Thank you. Sorry, I laugh a lot. I don't know, I'm not really good with this kind of thing. I prefer being at the back of the camera. I was forced to do this.